it knows how to do things like have local variables that are declared before the block is used work inside the block. Okay? So if I had that block and I wanted to stop not just when I see the key enough, but also when I see the value, stop value, which is a local variable defined in the scope that's calling the method enumerate keys and objects using block, I can use it. The compiler makes sure that the value of that gets properly passed in. However, a question?
Oh, is this statically scoped for using things outside?
Yeah, it is the local, whatever scope the A dictionary enumerate keys and objects, that call, whatever scope there, that's the scope in which the variables can be used, which is pretty much the local stack, right? The stack from your thing. Now, those variables, though, are read-only. Okay, so if I had another one, a bool stopped early, and I tried to set that inside my block, that would be an error. Compiler would not allow that, okay, because stopped early is read-only. However, there's actually a way to make it so it's not read-only, which is to put underbar block in front of it. If you put underbar block in front of a local variable, then the compiler will generate code that transfers stopped early off the stack into the heap so that it can be used by the block. And then when the block is finished, it'll copy the information back into the heap and then back onto the stack. Okay, all happens magically. So if you have underbar block, it knows to do that. So that's a little magic you put in there. Now your variables can go both ways. So now stopped early is yes is legal. Okay? This also works if the variable is an instance variable. We don't really access instance variables except for setters and getters. But that's because instance variables, of course, are in the heap, because all objects are stored in the heap. What about objects that are messaged inside of a block? Because there's a little special thing to think about there. So if I had a string stop key, which was enough, and I wanted to use stop key inside that block, like this, I have to make sure, well, not I have to make sure, the compiler has to make sure that it generates code, and the runtime has to make sure it works, so that stop key, that there's a strong pointer to it. Otherwise, it could leave the heap by the time this block executes, because this block could execute at any time. Okay? This block happens to execute immediately when you call this, but it's legal for the dictionary to grab this block and store it somewhere and execute it sometime later that it wants to. Okay? So every time you use it, listen to this carefully, every time you send a message to an object inside a block, a strong pointer is created to that object, and it stays around until the block goes out of scope, until the block no longer exists. Okay? As long as that block exists, a strong pointer to every single object in there, this message will exist. Before I talk about that, I want to talk about some shorthand. If the block has no arguments, like this block, see, no arguments there, you do not need to put the parentheses. Okay? You can just leave those off. And similarly, if the return value of the block, so this block, which is the first time you've seen a block with a return value, it returns a bool. See that bool? If the return value can be inferred from the contents of the block, right? So this case, return object is kind of class UI class, definitely going to return a bool. You do not need to put the bool there. In other words, if it can be inferred, it'll figure it out for you. Okay? So just syntax, it's just to clean up the syntax, so you don't have to put the bool in there all the time, or whatever. Okay, now let's talk about how blocks sort of act like objects. Blocks are not objects, okay? They're not, but they sort of act like objects only in this fine, really small way, which is they can be stored, okay? And they are reference counted by the automatic reference counter, okay? So storing them means they can be stored in variables, in properties, and in dictionaries and arrays, okay? So they can be stored just like they're objects, but they don't understand any messages like an object. Actually, they understand one message, which is copy, which is kind of an important message because that copies them in the heap, and if you want to keep a pointer to a block around, you probably want to copy it, okay? So that it doesn't just go off the stack of somewhere. So for example, here I am putting a block into an array. So I have a property in my class, myBlocks. It's a mutable array of blocks. And I just say self.myBlocks, add object, colon, a block. Okay? And I know this looks weird, and it is weird because blocks are not objects, but they act like objects for this purpose of storing them in things. Okay? So it's pretty neat. And by the way, I have not talked about basically how you would call this block. Like if I grab this block out of this array and wanted to invoke it, how would I do it? I'm not going to talk about that today, but I'm going to show you so that you can see it. Really, you're not going to have to do that in this class because you're going to be passing blocks to iOS and it's going to be executing them. But if you wanted to know, that's the syntax. It's kind of like C function syntax. You can look offline. I just don't have time to cover it, unfortunately. But there's a real danger lurking here, okay, in this code above. Okay, this self-do something thing. And what is it? Well, it's called a memory cycle. How many people know what a memory cycle is? Okay, not very many. Okay, that's good, so I'll cover this. A memory cycle, it's caused because all the objects inside that block have a strong pointer to them as long as the block exists. Okay, so for example, in this code, self, a strong pointer will be held by that block to self. You see why? Because the block, as long as it stays around in that array, it needs to be able to call self do something, so it needs to always keep a strong pointer to self as long as the block exists. However, the problem is that self has a strong pointer to the block through its myBlock array, right? Self has a strong pointer to myBlocks, which is an array. The array always hold their things strongly. So now both of them are pointing strongly to each other. The block is pointing to self, self is pointing to the block. Neither of them can ever leave the heap in that situation because there's always going to be a strong pointer to them, each other's, right? One of them can't leave first and make it so there's no pointer to the other because they are keeping each other in. That's called a memory cycle, okay? And we have to break these cycles. Hey, this is a serious problem. You definitely want to be able to break these cycles. And here's how we do it. We're going to do it with a local variable, okay? Now, local variables are all what? They're all strong, right? Local variables are strong. They're strong pointers into the heap. Pointer variables until the method ends, and now the strong pointer goes away, and so now that local variable obviously is not holding something in the heap by being strong. But there is a way to actually create weak local variables with underbar weak. Okay, underbar weak before a local variable declaration will make that variable weak. Okay, and remember that weak means it's not keeping the object in the heap. If no one else is pointing to it, it just goes away, and the weak variable gets set to nil. Okay, so I'm going to make a local variable, weak self, which points to self, but it's weak pointer to self. And now I can use that inside this block that I added. I'll send do something to weak self, and now I don't have this cycle anymore because the block no longer has a strong pointer to self. It has a weak pointer. Okay, so yes, we will do this. You might have to do it in your homework depending on how you decide to implement it. And I will definitely do it in the demo today so you can see how this works. Okay? This is really the only place we have these kind of cycles with ARC, with the automatic reference counter. It's not too bad. You just have to know it's there and deal with it. Okay? Okay. So when do we use blocks in iOS? We use them for enumeration. You saw that dictionary enumerate keys and values. We use it a lot for enumeration. We use it for view animation. I'm going to do a whole rest of this lecture, and start of next lecture is going to be about that. We use it for sorting. There's messages you can send to arrays like sort this array and use this block to compare two objects in the array. Okay? Notifications, right? When a radio station broadcasts, instead of sending a notification message, you can say, just execute this block when some broadcast happens on the radio station. Error handlers, very common. Do this thing, and if an error happens, execute this block and I'll handle it. Okay? Completion handlers, also very common. Do this thing that's going to take a long time, and it's going to be done in a background thread, and when it's done, execute this block to let me know. Okay? Animation does that. In fact, we'll see that in the animation too. Question?
So you have like a method defined in your class, and you want to use that function as a block. Is there any easy way to just refer to it, or do you have to like write it as a block?
Yeah, so the question is, if I had a method defined in my class or whatever, and I want to use it as the contents of the block, just call self and that method inside the block. And then that will call it. That's a common thing to want to do, actually. A very, very important use of blocks, which we're going to talk about later in the quarter, is multi-threading, okay? Which is getting your application doing multiple things at the same time. Not really at the same time, but seemingly at the same time. And I really encourage you, this is one of the few times I'm going to tell you, go look in the documentation to find out about blocks. Just search for blocks. in Xcode documentation. And you can find out things like how to declare a local variable that is a block and things like that, because I haven't really talked about those things. Mostly I've just taught you enough about blocks to be able to call methods that take blocks as arguments. Okay, that's all I've pretty much shown you so far. Okay, so that's it for the Objective-C that I wanted to cover. And now we can get into the fun stuff, which is animation. All right, so that's going to be the rest of today and probably the start of Wednesday, because this demo is really big. And there's lots of different animation that goes on in iOS. I'm going to talk today, and really only in this course for the most part, about animating views. Okay, you know how to create custom views, right? And you could even animate non-custom views, buttons or whatever you want. But basically making views move around the screen, get bigger and smaller, fade in and out, spin around and rotate. That's what we're going to talk about, okay, animating views. But there's other animation that goes on, like when you go into a navigation controller and you click and a new view slides in, okay, that's animation. All right, and it's possible also, okay, you're in the Maps app and you click in the corner and it curls up to show you other options. That's animation, okay? All that kind of view controller animation, I'm not going to talk about for the most part, okay? But that's all, there's all support for that as well. There's also a whole other thing in iOS called a collection view, which is a collection of views that kind of live in a grid, sort of, or in a flow kind of layout. And those all can be animated, what's going on in there as well. Okay, but I'm only going to talk about views. Underneath all of that is this framework called Core Animation. Super powerful framework. Okay, I mean, industrial grade animation framework there. But we're going to be doing it all at a much higher level, much easier to program, and kind of easier to. You don't have to know quite so much about the detail of how animation really works. Whereas core animation is really for animation, people who want to really do serious animations. And a lot of iOS applications are games or other things that have a very serious animation going on in there. By the way, in iOS 7, there's a lot of other things for doing animation. For example, Sprite Kit is a way to animate sprites, which are essentially 2D graphic elements that are being composited in a way to try and create a 3D looking environment, like a lot of video games are. And we're not even going to touch Sprite Kit, I don't think, unless we get to it the last week. So there's a lot of stuff that I can't possibly cover. So let's just talk the basics here of animation. So there's 3 ways to animate views, basically. Okay? The first way is that there are some very special properties in View, namely the view's frame. Remember, that's the rectangle enclosing it. Its transform, which we talked about briefly when we did the playing card thing. Transform is the view's scale, can be used to scale it up and down, and its rotation, the views can be rotated, and also translation, although usually for translation we use the frame, we move the frame around. And also alpha, its opacity. These 3 things can be animated at any time in a view, meaning you set them to a new value, and it'll set it to that new value immediately, but the effect will appear on screen animated over some amount of time. So let's take a look at how this works. It's done with a class method in UI View. Okay, a class method. It's not an instance method in UI View. It's a class method. And the class method basically takes the animation parameters, how long to take, and